Limiting reagent. Limiting reagent is the reactant which is completely consumed during the reaction and limits the amount of product is formed. That is called a limiting reagent. Okay, it means a limiting reagent means the reagents which gets consumed first. Okay, it limits the further reaction from taking place. It limits the further reaction taking place. Okay, this is called limiting reagent. Okay, so for example, we know the stoichiometric means the balanced chemical equation. Balanced chemical equation means the equation should be balanced. For example, balanced means 1 mole. For example, 1 mole of A. Okay, so for example, A reactant A plus B gives AB. A is 1 mole plus B is 1 mole gives AB is 1 mole. Okay, that is the balanced chemical equation. Otherwise we call this stoichiometric. Stoichiometric means balanced chemical equation. Suppose for the A we are taking 1 mole and B 5 moles and the product AB how much moles? 1 mole. Okay, so 1 mole of A reacts with 5 moles of B gives 1 mole of AB. Understood? So here this is non-stoichiometric. Okay, so 1 mole of A reacts with 1 mole of B gives 1 mole of AB product means this is stoichiometric. Stoichiometric means balanced. This equation is balanced. But in the case of 1 mole of A reacts with 5 moles of B, where we get 1 mole of AB means it is non-stoichiometric. What do you mean by non-stoichiometric? It is the reaction is unbalanced. Understood? So the 1 mole of A should be reacted with 1 mole of B. So here the A is the limiting reagent. Okay, so all the reagents will be consumed. That is called a limiting reagent. The reactant B we call this the excess reactant, excess reagent. Understood? So 1 mole of A should be reacted with 1 mole of B in 5 moles of B. So the 4 moles of B reagent B is excess. Okay, left the 4 moles of reactant B. Understood? So because of this B, the reactant B we call this excess reagent. The reactant A is called as limiting reagent. Understood? So what do you mean by limiting reagent? The limiting reagent is the reactant which is completely consumed during the reaction and limits the amount of product is formed. Okay, so total the limiting reagent, the reagent which gets consumed first. Understood? When I explain with an example, you can clearly understood here. For example, one of the example I am taking. Suppose in the preparation of kesari, recipe, you know kesari recipe. So what are the reagents we need? Rava and sugar. Okay, this is important things need to prepare kesari. Okay, here so 1 cup. Okay, if you want to prepare 6 cups of rava, we need 6 cups of kesari. We need 1 cup of rava. Okay, so rava is 1 cup. Okay, so 1 cup rava, it consumed 2 cups of sugar. So sugar here 2 cups. Okay, so rava 1 cup, sugar 2 cups. Okay, we can prepare 6 cups of kesari. Understood? So consider a situation where 8 cups of sugar and 3 cups of rava. Okay, the ingredients are the rava is 3 cups and sugar is 8 cups. We can prepare the 18 cups. 18 cups of kesari. Okay, so here which one is the limiting reagent? Which one is the excess reagent? You have to calculate which one is the limiting reagent, which one is the excess reagent. Here, you see here, we know the 1 cup of rava, the need 2 cups of kesari to prepare, 2 cups of sugar to prepare 6 cups of kesari. Here, 3 cups of rava added with 8 cups of sugar. Okay, 1 cup of rava, 2 cups of sugar means here for the 3 cups of rava means we want 6 cups of sugar. Okay, 3 cups of rava means we want 6 cups of sugar because 1 cup of rava need 2 cup of sugar. Okay, so 3 cups of rava means 3 into 2, 6 cups of sugar we need to prepare 18 cups of kesari. But here we are using 8 cups of sugar instead of 6 cups of sugar to prepare 18 cups of kesari. Okay, so we get only 18 cup of kesari only we get. Okay, so 3 cups of rava added with the 8 cups of sugar, only we get 18 cups of kesari. Okay, we cannot get more cups of kesari when we are adding 8 cups of sugar instead of 6 cups of sugar. Okay, so here the rava is the limiting reagent. Okay, so 3 cups of rava, we can prepare only 18 cups of kesari. Okay, so suppose we are adding 6 cups of sugar with the 3 cups of rava, we get 18 cups of kesari. Okay, so in the case of 8 cups of sugar we are adding in 3 cups of rava, we cannot get more than 18 cups of kesari. Okay, only the sweetness only we can increasing by adding the more 2 more cups of sugar. Understood the concept. So here the sugar, the rava is the limiting reagent, sugar is the excess. How much excess here? 2 cups of sugar here excess. Okay, so sugar is the excess reagent, rava is the limiting reagent. Understood? So another one example, I am going to explain another one example. You can clearly understand. Suppose one of the manufacturing company manufacture the parts of the car. Okay, automobile parts of the car. The manufacturing company preparing the automobile car parts. They prepare 32 tires and 12 headlights. Okay, the 32 tires, 32 tire how much? 32 and headlights how much? 2. Okay, so 12. Understood? So tire, you know the car, for one car how much tire we need? 4 tires we need. For one car how much headline we need? 2 headlines we need. Headlights. Okay, so the manufacturing company prepared 32 tires and 12 headlights. Okay, so tires here 32 plus headlights 12. Okay, so if you are to prepare one car, 4 tires we need and 2 headlights we need. Understood? So here for the 12 headlights we can prepare 12 headlights we can prepare how much cars? For each cars need 2 headlights. So 12 headlights, using 12 headlights, we can prepare 6 cars. 6 cars. Okay, understood. So 6 cars, how much tires need? 1 car means 4 tires. So 6 car means 6 into 4 into 6. 24 tires. To prepare 6 cars, 24 tires we need. Understood. 24 tires only we need. But the manufacturer company produced 32 tires plus 12 headlights. What is the product? Car. How much cars? 6 cars. Okay, here which one is the limiting reagent? Which one is the excess reagent? So 32 tires. Using 32 tires, we can prepare we can prepare 8 cars. Okay, we can prepare 8 cars. Using 32 tires, we can prepare 8 cars. But only 12 headlights only having here. By using 12 headlights, we can prepare, we prepare only 6 cars. Okay, so here to prepare 6 cars, how much tires we need? 24 tires only we need. 24 tires only we need. Understood. So 32 minus 24, we get how much? 8 tires extra. 8 tires excess having here. Okay, so to prepare 6 cars, how much tires we need? 24 tires only we need. But in the car manufacturer company, prepare 32 tires. Okay, so but only 12 headlights only having. So using 12 headlights only we are preparing, prepare only 6 cars only we can prepare. Understood. So 12 headlights fully consumed, totally fully consumed. 12 headlights to prepare 6 cars. Okay, but tires only 24 tires only used for to prepare the 6 cars. So remaining how much tires excess? 8 tires here excess. Understood. So here which one is the limiting reagent and which one is the excess reagent? Headlights is the limiting reagent and tires is the excess reagent because 8 tires left here. 8 tires balance having here. Excess having. So tires is the excess reagent and headlights is the limiting reagent. Understood? Okay, students, and another one chemical reaction I am going to explain. In which 3 moles of sulfur are allowed to react with 12 moles of fluorine to give sulfur hexafluoride. Okay, this is one of the reaction. How much moles? 3 moles of sulfur reacts with 12 moles of fluorine, F2, to give sulfur hexafluoride. Sulfur hexafluoride. How much moles? 3 moles. Okay, so here this is not balanced. Okay, this is not stoichiometric equation. This is not balanced. Understood? So the balanced equation is for the reaction is sulfur. There is 1 mole of sulfur. It reacts with 3 moles of fluorine. We get 1 mole of sulfur hexafluoride. Understood? So 1 mole of sulfur reacts with 3 moles of fluorine. So sulfur 1 mole, fluorine how much mole? 3 moles. We get 1 mole of sulfur hexafluoride. 1 mole. Sulfur hexafluoride 1 mole. So this is the balanced chemical equation. So but in the case of 3 moles of sulfur are allowed to react with 12 moles of fluorine means it is not balanced. Understood? So 1 mole of sulfur reacts with 3 moles of fluorine to form 1 mole of sulfur hexafluoride, and therefore 3 moles of sulfur reacts with 9 moles of fluorine. 9 moles. Okay, so you can relate this here. 1 molar sulfur reacts with 3 moles of fluorine. So 3 moles of sulfur reacts with 9 moles. Okay, 3 into 1. So one part of the sulfur react with 3 parts of the fluorine. Suppose 3 parts of the fluorine means sulfur. Sorry, 1 part of the sulfur reacts with 3 parts of the fluorine. Okay, so in the case of 3 parts of the sulfur can react with 9 parts of the fluorine. 3 into 3. 1 into 3, 1 part means 1 is to 3. So 3 moles of sulfur means 3 into 3 means 9 moles can react here. Okay, 9 moles of fluorine, we get 3 moles of sulfur hexafluoride. This is the balanced equation. But our equation is 3 moles of sulfur reacts with 12 moles of fluorine to form 3 moles of sulfur hexafluoride. 3 moles of sulfur hexafluoride. Okay. So here which one is the limiting reagent? Which one is the excess reagent? You know, sulfur here in the case of this reaction, that is 3 moles of sulfur reacts with 12 moles of fluorine to form 3 moles of sulfur hexafluoride. Here you know the sulfur 3 moles and the fluorine how much moles? 12 into 2, how much? 24. But here sulfur 3, here also 3, but here fluorine 3 into 6, 6 3s are 18. 18 moles of fluorine having here. 18 only having. But here, how much moles are having? How much moles? 12 into 2, that is 24. 24 atoms fluorine having here. Okay, 24 atoms. It is not balanced. Okay, so yeah, we can, here how much moles of fluorine left here? 3 moles of fluorine left here. When comparing the balanced equation, the non-stoichiometric, that is unbalanced equation, the 3 moles excess of fluorine having here. Understood? So 3 moles of sulfur can react with 9 moles of fluorine. We get 3 moles of sulfur hexafluoride. This is the balanced. But this is unbalanced, non-stoichiometric. Here 3 moles of fluorine react with how much moles fluorine? 12 moles of fluorine. We get 9 moles only we get. So 3 moles of fluorine here left. Understood? So which one is the limiting reagent here? Sulfur. Limiting reagent sulfur. Excess reagent fluorine. Because 3 moles of fluorine excess here. Understood? So this is the one of the example. Okay students, now we are going to study about one of the reaction, that is preparation of urea. Okay, urea you know. Urea is one of the fertilizer. Okay, so here how we can prepare the urea. When ammonia combines with carbon dioxide, we get urea and water. Okay, ammonia, here 2 moles. To prepare urea, we want 2 moles of ammonia. Okay, 2 moles, 2 NH3 plus CO2, carbon dioxide, all in gaseous phase, we get urea. Urea, that is, what is the formula for urea? That is otherwise called as diamide. Okay, amide group 2, amide group NH2, bond C, double bond O and NH2. Okay, this is the urea formula for urea, NH2 CO NH2, very very important. Formula for urea, NH2 CO NH2. Okay, carbon we know carbon has the 4 valencies, so here we have to make here double bond, carbon oxygen double bond. Okay, understood? So NH2 single bond carbon, double bond single bond NH2. This is the urea. It is aqueous state and the water. In this process, 646 gram of ammonia is allowed to react with 1.144 kilogram of carbon dioxide to form urea. How much gram? How much weight they are taking? 646 gram of ammonia to react with 1.144 kilogram of carbon dioxide to form urea. Okay, so what are the questions they are asking here? Which one is the limiting reagent? Which one is the limiting reagent? And second question, calculate the quantity of urea formed and unreacted quantity of excess reagent. Calculate the quantity of urea, how much urea, quantity, how much urea formed. Okay, and unreacted quantity of the excess reagent. Which one is the excess reagent? Unreacted quantity. Okay, that is the second question. Okay, so how we can calculate this quantity of excess reagent? Okay, we are using this tabular column. I can clearly explain you. First upon the reactant and products. What are the reactants? Here we are using ammonia, carbon dioxide. What is the product we are using here? Urea and water. Okay. First upon stoichiometric coefficient. Stoichiometric coefficient, that is, that is mole. Okay. Stoichiometric is balanced chemical equation. Balanced. So this equation is balanced or not? This is balanced because how much nitrogen here? 2 nitrogen. Here product side also 2 nitrogen. Hydrogen here 3 2s are 6 hydrogen. Here 2 plus 2 4 4 plus 2 6. Carbon here 1, here also 1. Oxygen here 2, here also 2. So this is the balanced equation. So stoichiometric coefficient here. Coefficient means the number used to balance the equation. Okay, so here for ammonia, how much moles are having? 2 moles. And the carbon dioxide, how much? 1. And the product side, urea, how many moles? 1 mole. And water, 1 mole. Understood? So next point, number of moles of reactants allowed to react. Number of moles of reactant. Then we have to calculate the number of moles. Because the question is quantity. Calculate the quantity of urea formed. Calculate the quantity of urea formed. And the excess reagent left over at the end of the reaction. Okay, so how much reagent excess? Okay, so amount of carbon dioxide left over. We have to calculate the quantity of urea formed and the amount of carbon dioxide left. Amount, we have to calculate the amount. So we have to know the number of moles using here. Number of moles. Okay, so number of moles. What is the formula to calculate the number of moles? Already we studied. Number of moles is equal to mass by molar mass. Mass by molar mass. Okay, so here mass is given. Mass is given. How much mass? 646 gram of ammonia. React with 1144 gram. Okay, 1.144 kilogram means that is in kilogram, but I am telling now the in gram. Okay, so 646 kilogram of ammonia reacts with 1144 gram of carbon dioxide. Okay, so that is the mass. Mass is for ammonia 646 divided by what is the molar mass of ammonia? Ammonia molar mass, nitrogen 14 plus how many hydrogen are having? 3 hydrogen. So 14 plus 3 17. Okay, so 646 divided by 17 is equal to 38 mole. Okay, 2 moles of ammonium is how many moles? 38 moles. And next, carbon dioxide 1144 divided by what is the molar mass of carbon dioxide? Carbon 12 plus oxygen 16 into 2, totally we get 44 gram per mole. So molar mass of carbon dioxide 44. So dividing the number of mole is equal to mass by molar mass. So mass is 1144 divided by 44 to get 26 moles. 26 number of mole 26. Okay. So next, actual number of moles consumed during the reaction ratio. Actual, how much number of moles consumed. Okay. So that is the limiting reagent. So that is so reactant, how much reactant? 2:1 ratio. Reactants are reacting here 2:1 ratio. Okay, so ammonia, 2 moles. 2 moles means how many number of moles? 38 moles. 38 moles. So 2:1 ratio. Okay, actual number of moles consumed during the reaction ratio 2:1. So this is 2 means 38. 2:1 means 38 divided by 2. 38 divided by 2, we get 19 moles. So carbon dioxide actual number of moles are consumed during the reaction ratio, that is the carbon dioxide, 1 number of moles, stoichiometric coefficient 1 mole. So number of moles 26. So 30. So here actual number of moles consumed during the reaction rates, reactant ratio, that is 38 divided by 2, we get 19 moles. So next line, number of moles of products thus formed. Number of moles of product thus formed. So this is the reactant side. Next we are going to write the product side. Number of moles of product. How much moles of product is formed? How much moles? 19 moles of urea and 19 moles of water is formed. 19 moles of urea and 19 moles of water is formed. Because totally how much moles they are consumed? Totally 19 moles. So 19 urea 19 moles and water 19 moles. Okay. So number of moles of reactant left at the end of the reaction, that is totally so how many carbon dioxide reactant the ammonia is the limiting reagent. All ammonia molecules are reacted 38. Carbon dioxide is the excess reagent, that is 26 moles. So how can you calculate the number of reactant left at the end of the reaction? That is 19 minus, sorry, the carbon dioxide is, that is the carbon dioxide is the excess reagent. So how many quantity, how much carbon dioxide is the left over? So here 7 moles. Okay, 7. Why it is 7 moles? Number of moles into molar mass. Number of moles into molar mass. Okay, so mass is quantity means mass. Mass is equal to number of moles, 7 mole into 44 gram per mole. 7 mole means carbon dioxide. So totally 26 moles react here. How much moles consumed? Totally 19 moles only consumed here. So the number of moles of reactant left at the end of the reaction, so 26 minus 19, we get 7 moles. 26 minus 19, 7 moles. Okay, so the quantity, so the what is the limiting reagent here? Ammonia is the limiting reagent, and the balance the equation is 2NH3 plus CO2 gives to NH2 CO NH2 plus water. And what is the third question? Quantity of urea formed. Urea quantity means mass. Quantity means mass. What is the formula to calculate the mass? Is equal to number of mole into molar mass. Number of mole into molar mass. Okay, so quantity of urea formed. So number of mole of urea. How much moles of urea is react here? How much number of moles of urea? 19. 19 moles are formed into. So what is the molar mass of urea? 60 gram per mole. Urea, ammonia, N 14 into 2 plus carbon 12 plus oxygen 16 plus hydrogen 2 plus 2 4. Totally 60 gram per mole. So 19 into 60 is equal to 11140 gram. Is equal to how much kilogram? If you are using in kilogram by divided by 2, so 1.14 kilogram. Okay, understood. So next, what is the next question? Excess reagent. Excess reagent left over at the end of the reaction. Left over. excess reagent left over at the end of the reaction is amount of carbon dioxide left over is equal to amount of carbon dioxide. So mass is equal to number of mole into molar mass. Number of moles of carbon dioxide into molar mass of carbon dioxide. So it's equal to number of moles of carbon dioxide. How much moles? 7 moles. 7 moles left. 7 into 44. We get 308. Okay students, today your assignment. 3 questions I will give today. Question number 1. Write the balanced equation of formation of urea. Question number 2. Calculate the quantity of urea formed. Question number 3. Calculate the quantity of carbon dioxide left over. Okay. Have to study and write and send me through my WhatsApp number. Thank you students. Thank you.